Good day students, today we are taking the topic of ninth class, matter in our surroundings. So first of all, let us define matter. What is matter? Matter, as we know, it is anything which occupies space, possesses mass, and it works when it has some extra energy. The old definition is it can be felt by any of our five senses. Nowadays it is defined as anything which occupies space, possesses mass, and it works when it has some extra energy. So this is matter. So things around us, they are or material in nature. The air around us, it is the gaseous state of matter. The water around us, it is the liquid state of the matter. And the buildings, the concrete, the bricks, the stones, the pebbles, the sands and stones, all of these are the solid states of the matter. So in our surrounding, we are dealing with the three states of the matter. So matter is divided into three parts, that is solid, liquid, third state is gas. As we know, solid is that state of matter which has definite mass, shape and volume. So solid state, it has definite mass, shape and volume. Coming to the liquid state, in liquid it has definite mass and volume, but no definite shape. Then we come to gaseous state. It has definite mass, but no definite shape and volume. So these are the three states of matter. Then we come to the another classification of matter, that is called as classification chemical classes. According to this system, solid is made of three states: element, second is compound, and third is mixture. Element, it is defined as the pure state of the matter which can neither be decomposed into nor be built from simpler substances. Then we have compound, it is formed by combination of two or more elements in a fixed ratio, fixed proportion by weight. So element, we have number of elements: copper, silver, gold, zinc, hydrogen, helium, etc. All of these are elements. Then we come to compound. Compound, they are the combined state of the matter. So they are the two types: inorganic and organic. Organic compounds, they are covalently bonded compounds of carbon. They are alkanes, alkenes, alkynes, arenes. Inorganic compound, the salts which we are using at home, we are using K2SO4, we are using number of fertilizers, we are using KCl, all these salts, we are using potassium, commonly it is called as fit curry. Then we come to mixture. They are of two types: homogeneous and heterogeneous. Homogeneous mixtures are those mixtures which have uniform composition throughout. They do not change their composition. For example, when sugar is dissolved in water, it completely dissolves in water. That gives us homogeneous mixture. Then we have heterogeneous mixture. If sugar is partially dissolved in water, half of it is present in dissolved form, half of it is present in the undissolved form. That gives us heterogeneous mixture. So these are the two systems of classification of matter. First system is depending upon physical state. This system is called as physical classes. Then we have chemical classes. Physically matter is three states: solid, liquid and gas. And in the chemical classes it is also consists of in three states, that is element, compound and mixture. Then we come to the what kind of forces they are present in these states. So nature of forces, we will be talking about the properties of these three. Number one for solid, number two is for liquid, three is for gas. So solid, first of all, these three properties we have compared. This is first point of comparison between these three states of the matter. Second point is nature of forces. They are strongest. Particles are closely packed. The nature of forces are so strong that it is very difficult to separate the particles of solid substance. Then liquid, they have moderate forces, neither strong nor they are having weak forces. Liquids are gases, they have weakest of the forces, weakest interparticle forces. So this is the second point of difference between these two states of matter. Then we have the empty spaces, third property. They are least, they are moderate in liquid, they are maximum in gases. Then we have compressibility, least compressible, these are moderate, they are maximum compressible. This is our fourth property regarding compressibility. Then we have order of the particles. If the particles are orderly arranged, they are maximum orderly arranged in the case of solid. They have moderate order in this liquid state, and they have least order in the gaseous state. Then we come about the properties of these substances. Because we have studied the solid, we have studied liquid, we have studied gases. Now let us see whether these three states, they are interconvertible or not. So, and on interconversion we will be studying there are some specific properties. By change of those properties, their state can be changed. So we come to interconvertibility. Solid can be changed into liquid, that is at the melting point of the solid, and liquid can be changed into gas, that is boiling point. And the heat required to change 1 kilogram of solid into the liquid at its melting point, that is called as latent heat of vaporization. Latent heat of fusion, delta H fusion. And the heat required to change 1 kilogram of liquid into gaseous state, that is called as latent heat of vaporization. So we will be doing these four definitions which are used during the conversion point. Then what is the melting point of the solid? It is the temperature at which the solid just changes into liquid. Then we have boiling point of the liquid. It is the temperature at which the liquid just changes into vapors, or it is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure, that is boiling point. Then what is boiling? Boiling is a bulk phenomena which involves the change of whole liquid into vapors. Now, what is evaporation? So this is definition 1, 2, 3, 4, and now we are having fifth definition. It is the formation of vapors by a liquid below its boiling point. अपने boiling point से पहले liquid का vapors में बदलना, that is called as evaporation. And the vapors of the liquid, they are not so energetic during evaporation, since they don't have the much energy in that state. Then we have evaporation. It is a surface phenomena, and the result of evaporation is always it causes cooling. For example, if we are keeping a water in a container in a pitcher which is having small holes, the water evaporates through these small holes, and when water evaporates, it takes away some energy from the surface, therefore surface, and the water inside the pitcher that gets cooled down. It is mainly because of the result of evaporation, because evaporation always causes cooling. It is due to this fact the water in a pitcher that becomes cool. Then we have sublimation. Sublimation is a phenomena where solid directly changes into gas. What is sublimation? It is the phenomena at which the solid just passes into the gas without involving the liquid state. This is called as sublimation. The iodine, it is sublimizable compound. Naphthalene is a sublimizable compound. Benzoic acid is a sublimizing compound. Similarly, naphthalene, it is also a sublimizable compound. Then we have the next property of the measurable properties of the matter. Mass of the solid, it is expressed in kilogram. Liquid, kilogram. Gases can be expressed in kilogram. Quantity is expressed in moles. That is given by n is equal to W upon n. Then we have volume. Volume is measured in cubic meters. Cubic centimeters. Then we have temperature. Temperature is expressed in 3 scales. First scale of temperature is centigrade. It is based upon water. It starts from 0 degree centigrade and ends at 100 degree centigrade. This is melting point of water. This is boiling point of water. Then we have Fahrenheit scale. It is also based upon water. Melting point taken here 32 degree Fahrenheit. Boiling point taken here 212. There are 180 divisions in this scale. Here we have 100 divisions in this scale. So this is second scale. Then we have Kelvin scale. Here temperature T Kelvin. It is equal to 273 plus T degrees centigrade. This is called as T Kelvin temperature. So these are the measurable properties. First of all, we have taken the mass, volume, and then temperature. Pressure, that is usually expressed in case of the gases, that is expressed in the atmospheres, that is expressed in pascals, kilopascals, Newton per meter square. And then in liquids and solids, their pressure is not solids, they don't exert any pressure. And this is regarding the measurable properties of the solid, liquid, gases. Then we have few more properties. They are, what is the freezing point of water? It is your 0 degree centigrade or 273 Kelvin. Then water boils at 373 Kelvin or 100 degree centigrade. Latent heat of fusion, it is measured in terms of kilojoule per kilogram or kilocalories per gram. Similarly, latent heat of vaporization, it is measured in kilojoule per gram or kilocalories per kilogram. So this is regarding the pressure is expressed, we have already done, that is in pascals. Or now, what are the units for temperature? Generally, temperature is expressed in Kelvin. Length, it is expressed in meter. Then mass, kilogram. Weight of the substance, that is Newton. And then volume, it is expressed in cubic meter. Density, kilogram per cubic meter. Then we have pressure, it is expressed in pascals. So this is regarding the measurable properties of the states of the matter. Then we have few more properties. We see the compressibility, we have already seen. Rigidity, that is maximum in case of the solid, they do not change their place easily. We require lot of energy to change their state. And the liquid have moderate rigidity while gases are not rigid at all. Density, maximum density is possessed by solid, that is moderate in liquid and very low in case of the gases. Then we have the kinetic energy, that is very small in case of solid. In liquid it is moderate, and in case of gases it is maximum. Then we have fluidity. Fluidity is that property of the matter by which molecules of a substance can flow from one point to another point. So gases and liquids, they possess, liquids and gases, they possess maximum fluidity. Solids have the least. Then filling of a gas container, it is a gas fills the available space, all of the available space. It is mainly because of the more empty spaces and weak van der Waals forces. They can easily fill up the given space or allotted space in the nature. So this is regarding the first unit, theoretical portion of the first unit, matter and its surrounding. In second lecture, we will be taking the textbook questions from 9th class. Thank you very much.